In today's video, here is a nice problem. It's coming from the Serbian Mathematics Olympiad edition 2005. Here is the following statement. We have a, b, r positive integers such that we have these following conditions. We have k equals square root of a square plus b square over 2. We have a capital A equals a plus b over 2. So if we have this condition, if we have this fraction k over a is a positive integers, so our goal we are going to prove a equals b. Okay, this problem may have several ways to solve it. If you guys can give the hands to this problem pre-get solution, go ahead pause this video when you come back to solution. Okay, let me know in the comment section below what you get. Okay, by the way, don't forget to hit the subscribe button and support our channel by comments and like. Let's go ahead and get started. So we are going to start with this fraction because this one we are going to use it as a tool because it's giving us this one must be as a positive integer. So let's write this one down. So I get k over a. So by putting this one on this one, I get square root of a square plus b square is divided by 2 all over a plus b over 2. Okay, so let's multiply numerator and denominator by number 2 here. We get 2 cancelled out from here. Since we have number 2 here, let's put this number 2 inside of the square root. It becomes 4 here. So we will have 4 over 2, which is 2. So we get square root of 2 is multiplied by a square plus b square all over a plus b. Okay, they give us k over a is a positive integer. Let's put this one as a m, which is a positive integer. Okay, so in order to have this fraction as a positive integer, we must have inside of the square root positive integer, and also the whole fraction must be a positive integer as well. Okay, let's start with this one. Let's go through these two informations. So I get here this one a square plus b square equals 2 times x square. Why is that? Because if you replace a square plus b square with 2x square, I get 2 is multiplied by 2, which is 4 x square. So we will be able to take this one out of the square root. So this will have a perfect square here. So this perfect square will be cancelled out this radical. Okay, then let's save this one for later. This is number 1. Okay, number 2, I will have the whole fraction, which is square root of 2 is multiplied by a square plus b square all over a plus b must be a positive integer. Okay, so let's work on this one by crossing the multiplication here. So I get m factor a plus b equals this square root of 2 is multiplied by a square plus b square, like this. Okay, the next thing up, let's square both sides. Squaring both sides, I get this square cancelled out this radical down to this quantity here. So which means I get 2 is multiplied by a square plus b square, like this. Okay, then replacing this a square plus b square with 2x square, I get 4 times x square. Okay, then expand this one out. I get m square here factor a square plus b square plus 2 times ab, which equals this one equals to 4 is multiplied by x square. Okay, let's also replace this a square plus b square with 2x square here, and then expand this one out. I get 2 times m square is multiplied by x square plus 2 times ab is multiplied by m square, which equals 4x square. Okay, so we see number 2 here, and number 4 here. So we are going to divide both sides by number 2. If I'm going to do that, I get number 2 cancelled out. This one it will be cancelled out down to number 2. Since I get x squared here, let's bring this term to the right and leave this one at the left side. Okay, So we get here the following. We get EB factor m squared equals x squared factor, by taking x squared as a common factor as well, I get 2 minus m squared. Here is a good thing here. We know this is the positive integer. The product EB is a positive integer. We know m squared is a positive. So the left hand side of this equation is strictly positive, which means the right hand side of this equation must be strictly positive as well, like this. So which means this one 2 is strictly superior than m squared. Okay, so let's flip this inequality. So I get here m squared is strictly inferior than number 2. Since m squared is a positive integer and we have this strict inequality, which is, this one is telling us m must be equals 1. Okay, is not 0 because we are dealing with the positive integers, not included 0 here. So we found the value of m which equals 1. Let's take this value of m and insert it back into the original fraction. So I get number 1 here, get m which equals number 1. Let's cross and multiplication. I get this big square, I get this square root equals a plus b. So from number 2 I get the square root of 2e squared plus b squared equals a plus b. Okay, let's erase number 2 as a power on both sides and expand this one out. I get here 2 times e squared plus b squared. Let's distribute this one out at the same time. Get e squared here plus b squared plus 2 times ab. Okay, so we are going to cancel out e squared plus b squared from both sides. I will cancel out down this number 2 down to number 1 by taking 2ab to the left side. So I get here e squared plus b squared minus 2 times ab. We know this one is going to be written on the form of the quadratic. So I get here a minus b quadratic squared equals 0, because thus a equals b. Okay, so we have proven our question here. So I have finished with this problem. Thank you for watching. I will see you next video. Bye.